Okay, we're going to start talking about piecewise functions this week. And let me just remind you, a function exists when every independent variable has exactly one dependent variable. Okay, so it passes the vertical line test. A piecewise function, just think of it as several functions put together. So several pieces of a function to make several different functions put together to make one new function. Okay, so it's a combination of two or more functions that are defined over specific intervals. So this specific example has the horizontal line f of x equals 5. Okay, so say that that looks like that. And then f of x equals x, we'll just say that's this graph. And then f of x equals -5, we'll put that down here, that's that graph. But I'm only looking at the 5 for all values greater than 10. And so maybe that's just out here. I'm only looking at the x from 5 to 10. So let's just say that that's maybe, just this part of it. And then I'm jumping down here and looking at this part of that f of x equals -5 from 5 down. So just the black parts of the graph are being defined. So here's an example of another piecewise function. And they're asking you to evaluate the function at specific values. In other words, if the y-coordinate is 5, they're saying, or I mean the x-coordinate is 5, what is the y-coordinate? So when I look at this graph and I look at where 5 is, and then I see that it's filled in right here, that tells me that the y-coordinate is -1. If I look at where 2 is, so let me just do a different color. If I line this up at x equals 2, can you see that the y-coordinate looks to be 3? Okay, so they're giving you the x and asking you to look on the graph and find y. Let's look at a different example. Okay, so evaluate this function graphically. Okay, so they're saying at x is 2, what is y? So here's 2, and y is down here at -4. What's happening at 0? Well, at 0, I can see that it's filled in right here at -1. What's happening at -3? If I go to x is -3, well, the y-coordinate is up here at 4. Okay, so part of the assignment, you're going to be looking at a graph, and then they're going to give you x, and you have to find what y is. The other part of the assignment is they're going to give you a function and ask you to find what the y is from the given x value. In other words, here, f of 20. You have to go to this piecewise function and look at this part of it to figure out where does 20 fit in these inequalities. Well, I can see that 20 is a number that's greater than 10. So that means that f of 20 is 8. So in other words, any value greater than 10 is going to be 8. Look at f of 8. Where does f of 8 fit in? Well, 8 is a number between 0 and 10. So that means I have a function there, 1/2 x. Well, that means put 8 in for x, so I get 4. Okay, f of 2, what branch? The top, the middle, or the bottom does 2 fit into? Well, up here at the top again. X is greater than, oh, no, that's wrong. In the middle. 2 is between 0 and 10, so now I have 1/2 of 2. Well, that's 1. Let's try a number lower than 0, f of -4. -4 fits in this inequality. That's a whole number, it's -5. So if there's a spot for you to put x in, you plug it in, and if not, then that means that's a horizontal line and it's a constant. Let's look at a different example. Here, example number 1. This is just a straight up function. There aren't any branches or pieces to it. Okay, there's only one piece to this function. If I want to know f of 0, I'm going to just plug it in. So that would just give me -5. If I want to know f of 1/2, I'm going to plug it in. So that's going to give me 1 minus 5 is going to give me negative 4. F of x plus 2, well, that means I'm going to plug in x plus 2. Okay, and you can distribute the 2 and simplify or leave it like that. The one on the right, number 2, well, that's a piecewise function. There's 2 pieces. F of 0, where does that fit in, the top branch or the bottom? Well, because this is greater than or equal to 0, then f of 0 is going to fit in there. So I'm going to do 6 times 0 plus 4. That would equal 4. F of negative 8, where does negative fit into the inequalities, the top one or the bottom one? It fits in the top because negative 8 is less than 0. So then I'm going to use that function and plug in negative 8. So I get negative 16 minus 5, or negative 21. Let's do another one. Find f of negative 2. You need to look at each inequality, the top, the middle, and the bottom, and figure out where does negative 2 fit in. Is negative 2 less than negative 2? No, so it doesn't fit in the top, so I'm crossing off the top. Does negative 2 fit into x being greater than or equal to negative 2 and less than or equal to 3? Yes, it's the middle branch. Negative 2 is not greater than 3, so it doesn't fit in there. So you find that what it fits in, and then you plug it in. Here's my function. I'm going to put negative 2 in for x. So what do I get? I get 0. Okay, so I want to just erase this quick and ask you, where would f of 5 fit in? Top, middle, or bottom? Well, 5 is a number that's greater than 3, so I'm going to plug 5 in right there. So I'm going to get negative 2 times 5 plus 7. So negative 10 plus 7 is negative 3. Okay, so you got to figure out what branch it goes in. Let's do just one more. F of 0, you need to be thinking in the top or the bottom. It's in the top. So 2 times 0 plus 2 equals 2. F of 5, top or bottom? Again, it's the top because 5 is greater than or equal to 0. So I get 12. F of negative 6, that's the bottom. That's a number that's less than 0. So then I take negative 3 times negative 6 plus 5. So I get 18 plus 5, which is 23. All right, folks, you're going to go to Delta Math, evaluating piecewise functions. And this is just between you and me. Reach out if you have questions.